Okay, good afternoon to you, and I'm so glad that you joined us for our Learning Together session today. Last time we met, we discussed factoring simple quadratic trinomials. For example, if we had, say, x squared plus 9x plus 14, and we're asked to write that as a product of, say, two binomials, we discussed that there is a way to do that. We could set up our two binomials, and we find, because there's a 1 right here, that it becomes very easy to find the numbers that would work perfectly. So we'd have x here and x, because x times x gives you x squared. And we ask ourselves the question, what two numbers multiply to give you 14 and add to give you 9? That was the essence of last session that we had. Today, we're going to move into more advanced type of factoring. So in this case, we know that 7 times 2 gives us 14, and 7 plus 2 gives us 9. So we could put 7, and we could put 2. And this, if you were to multiply this out and simplify, you will get that. So that was what we did last time. Today, we're going to move up a notch and start off by factoring those cases where the lead coefficient is not 1, where the lead coefficient is a different number. And that is what we're going to work on now. Okay. Here is our first example. Suppose we were asked to say factorize, say, let's use a simple one. 3n squared minus 16n plus 20. 3n squared minus 16n plus 20. This is significantly different from those that we did last week. Much different. And there is a method to the process. And what I would like to do to start is to explain the process first, and then we'll go and do this example. So this is what I wanted to point out. Once that number is not 1, the work becomes different. So the question is, what is the process? What is the process? Okay, and I'm going to go through the steps. There are about 3 or 4 steps, and then we'll do this example. So let's go. What does it say? Factoring ax squared plus bx plus c when a is not equal to 1. Not equal to 1. Step 1. Find the product a, c. In other words, take a and multiply times c. A times c. Step 2. Find two numbers that multiply to give AC and add to give B. So we're looking for two numbers that multiply to give you the number AC that you got for step 1. They must multiply to give you AC, and they must add to give you B. Step 3. Replace BX with two terms using the numbers from step 2. The two numbers that we get from step 2, we're going to take those two numbers and replace BX using two terms. And then last step, step 4, group and then factorize. So those are the 4 steps. I like to give the steps and then we practice. So let's go over again. We need to get this factorized, ax squared plus bx plus c, where a is a number which is not 1. First thing first, we multiply a times c and we get a product ac. Then we find two numbers that multiply to give us ac and also add to give us the middle term b. Once we get those two numbers, we go to step 3. We replace the middle term, that middle term using the two numbers that we got from step 2. So now we're going to end up with 1, 2, 3, 4 terms. We're going to get 4 terms because the middle term was now replaced using 2 terms because of the two numbers we got. Then we're going to group the first 2 terms and factorize, group the second 2 terms and factorize, and put it together. Boom, there it is. So let's go take a look at this example and see how it works. Because I'm from Jamaica, I give this process a name. I call it the AC dance, the AC dance. So let's go. A equal to 3, B equal to negative 16, and C equals to 20. A is 3, B is negative 16, C is 20. A times C is equal to 3 times 20, which is equal to 60. What two numbers multiply to give us 60 and add to give us negative 16? The two numbers that I think of, first of all, they multiply to give us positive 60, so they must be the same sign. They add to give us negative 16, so the fact that they add to give us negative and they are the same sign means that there are two negative numbers. The numbers that we would get would be negative 6 and negative 10. Those are the two numbers we're getting from step 2. Step 3, we're going to replace this number, this term, using negative 6n and negative 10n. So 3n squared minus 6n minus 10n plus 20. Notice we had negative 16n before, Now we have negative 6n and negative 10n. Put them together, we still have negative 16. So we haven't changed the value of the equation, we have just changed the representation. Not the value, just the representation. So now the last step, say we group these two and factorize. What is common to these two terms? The numbers are 3, and of course the letter will be n. So 3n will be common to these two terms. When you factor out the 3n, we end up with n minus 2. Go to the second group. What is common to this group here? A negative 10. So we factor out a negative 10, and we end up with n minus 2. Let's check. 3n times n, 3n squared. 3n times negative 2, negative 6n. Negative 10 times n, negative 10n. Negative 10 times negative 2, positive 20. Watch this. What's inside both parentheses are identical. Take note, if they are different, it means that you made a mistake. If these two things are different, you made a mistake. They must be the same. And if you do it properly, they will be the same. Okay? And then this is common to this, and this is common to this. So we can finish the job by writing n minus 2 times 3n minus 10. N minus 2 is common, so I can factor the n minus 2. The 3n goes here, and the negative 10 goes here. This is the result. I promise you that if we multiply these two things out and simplify, we will get exactly what we started with. Promise. Guaranteed. Okay? I'm sure you're going to say to me, why don't you check it? Let's see if we have enough space to check it. Let me see. If I write here, can we see? Okay. I'll write on a small board. So we have n minus 2 times 3n minus 10. N minus 2 times 3n minus 10. There it is. There it is. Same thing. I am going to check to see that we end up with that. N times 3n, 3n squared. N times negative 10, negative 10n. Negative 2 times 3n, negative 6n. Negative 2 times negative 10, positive 20. These two items, 3n squared minus 16n plus 20. There it is, same thing. Okay, let's try another example. Another example. Okay, how about let's try 2x squared minus 3x minus 5. How about that? Again, we do not have a 1 here, we have a 2. So that makes it a candidate for the AC dance. A equals 2, B equal to negative 3, C equal to negative 5. Okay? Okay. AC. A times C is 2 times -5, equal to -10. So A times C is -10. What are the two numbers when multiplied to give you will give you -10, and when added together gives us -3. They multiply to give us -10, so therefore there are two different signs, one positive, one negative. And when you add them, you get -3. So the only thing I could think of would be +2 and -5. +2 and -5, let's check. 2 times -5 is -10. 2 plus -5 is -3. So that works. So now let's replace this middle term with two terms. We end up with 2x squared minus 2x. By the way, it doesn't matter if I go the -5 here and the 2 there, we will get the same answer. It does not matter. So it's 2x squared this is plus 2x, positive 2x, -5x, and -5. Again, the 2 is positive, so it's positive. The -5 is negative, so it's -5x. Okay, we group these two, and we group these two. What is common to these two things? 2x. When I factor out the 2x, what is left inside? Factor out the 2x out of 2x squared, we end up with x plus 1. Let's check. 2x times x, 2x squared. 2x times 1, 2x. What is common to these two terms? -5x minus 5? The answer is -5. Factor out the -5, we end up with x plus 1. Let's check. -5 times x, -5x. -5 times +1, -5. Notice the two parentheses are identical. They are identical. So we finish the job by putting x plus 1 times 2x minus 5. And this is the factorization of that. I promise you, if you multiply these two things, you will get that. Now, I did say to you that it doesn't matter if you put the -5 first and the 2 after. I'm going to work and show you that we get the same result. I'm going to do that right now. So what is the result we're looking for? The result we're looking for is x plus 1 times 2x minus 5. That's what we're looking for, x plus 1 times 2x minus 5. I am going to switch these two numbers around and show you that we end up with the same answer. Let's go. So now we're going to write 2x squared minus 5x plus 2x minus 5. Group these two, we group these two. What is common to these two? X and x. When I factor out the x out of this, I'm left with 2x. When I factor out the x out of this, I end up with minus 5. Let's check. X times 2x, 2x squared. X times -5, -5x. What is common to these two things? The only thing that's common is +1. That's the only thing that's common to those two different terms. So if I put 2x minus 5, let's check. 1 times 2x, 2x. 1 times -5, -5. So this is common to that. So therefore we can write 2x minus 5 times x plus 1. Is it the same thing? X plus 1, x plus 1. 2x minus 5, 2x minus 5. It's just the one way around. But remember, 3 times 4 is 12. 4 times 3 is 12. It doesn't matter which one goes first. It's the same product. It's actually called the commutative property. It's called the commutative. And that's spelled C-O-M-M-U-T-A-T-I-V-E. The commutative property of multiplication, A times B is always equal to B times A. The order is not important. You still get the same result. Okay? Let's try one more example, and then I think you're pretty good with the AC dance. Okay, so what about this one? Okay. (6k squared minus 10k plus 50). 6k squared minus 10k plus 50. Before you start to factorize this, if you look at it, you notice that all 3 numbers can be divided by 2. So before you start going crazy, just factor out a 2 to get started. So this is the same as 2 times 3k squared minus 5k plus 25. The 2 is a common factor of all 3 terms. So now we just need to factor this trinomial right here, the 3k squared minus 5k plus 25. So our result is going to be 2 parentheses, parentheses. That's going to be our final result. 2 outside and 2 binomials. Okay? So let's go ahead and work on this. So we don't need to worry about the 2 now. We just need to worry about this, and then we just put the 2 right in front. So here goes. AC is equal to 3 times 25 equal to 75. Oh. Okay, this cannot be factorized. They made a mistake. This paper has a mistake on this. There's no way this can be factorized. Okay, this cannot be done. 2 comes out 3k squared, -5, 25. There's no way. It cannot be done. It's impossible. So let's go to a different question. Whoever typed this up made a mistake on this paper. Okay, let's try a different one. Okay. Okay. 3n squared. Actually, let's do this. 6n squared plus 20n minus 16. 6n squared plus 20n minus 16. Here goes. So this is equal to 2 times 3n squared plus 10n minus 8. And now we focus on this. A times c is equal to 3 times negative 8, which gives us negative 24. So our AC is negative 24. What two numbers multiply to give us negative 24 and add to give us positive 10? Multiply to give us negative 24, add to give us positive 10. I can think of 12 and negative 2. Let's check. 12 times negative 2, negative 24. 12 plus negative 2, positive 10. I think we got it. So now we can replace the middle term with these two terms. We have 3n squared plus 12n minus 2n minus 8. Group these first two, group these last two. What is common? We see 3n times n plus 4. Let's check. 3n times n, 3n squared. 3n times 4, 12n. What is common to negative 2n minus 8? I think we can do it negative 2. Factor to negative 2, we have n plus 4. Let's check again. Negative 2 times n, negative 2n. Negative 2 times positive 4, negative 8. N plus 4, n plus 4. So therefore, the factorization of this is n plus 4 times 3n minus 2. So therefore, the final answer to this must be equal to 2 times n plus 4 times 3n minus 2. Okay? So, what I'm going to show you now is how we can use this knowledge to solve quadratic equations. Okay? So in a previous discussion, in a previous lesson, previous tutorial, we talked about the zero product property. The zero product property. So based on that, we know that it says that if A times B equal to 0, then A is equal to 0 or B is equal to 0. I'm just repeating that fact for you. So if I say to you, solve x squared minus 3x minus 28 equal to 0. If I ask you to solve that, you could go ahead and say, oh, okay, I could factorize this, and now that I have it factorized with something times something, I might be able to use the zero product property. So here we go. We go zoom, zoom. This is 1, so I can go ahead and put my x and my x. And the two numbers multiply to give me negative 28 and add to give me negative 3. If I'm not mistaken, I think it will be negative 7 and positive 4. Negative 7 and positive 4. Let's check. Negative 7 times 4, negative 28. Negative 7 plus 4, negative 3. So perfect. Okay, so now we have something times something equal to 0. So the zero product property says x minus 7 is equal to 0 or x plus 4 equal to 0. When I solve this, I get x equal to 7 or x equal to -4. Look at it. This is how we get our two answers that we're looking for. It's squared, so you're looking for two answers. There it is. Okay? Let's try another one. Let's choose, okay. Solve 2m squared plus 3m minus 27 equal to 0. 2m squared plus 3m minus 27 equal to 0. Well, AC is equal to 2 times -27 equal to -54. What two numbers multiply to give us -54 and add to give us +3? Okay, I think of 9 and 6. 9 times 6 is 54. Since it's negative, one is positive, one is negative. So the positive, when you add them, you get positive that. So therefore, I think we're talking about +9 and -6. Let's check. 9 times -6, -54. 9 plus -6, +3. Perfect. So now we can rewrite this equation as 2m squared plus 9m minus 6m minus 27 equal to 0. We group, and we end up with m is common to this. We have m plus 9. And over here, we have -3. And we have 2m plus 9. Let's double check. N times m, it's supposed to be 2m. M times 2m, 2m squared. That doesn't look good. Let's edit. M times 2m, 2m squared. M times 9, 9m. -3 times 2m, -6m. -3 times +9, -27. So this is common to this, so we put 2m plus 9 times m minus 3. And now we can use the zero product property. We get m equal to 3, and this one gives us m equal to -9/2. I don't know if the space is here. You can see, but right here I can put 2m plus 9 equal to 0. Subtract 9 from both sides. 2m equal to -9. So m is -9/2. And for the other one, m minus 3 equal to 0, so m equal to 3. So our two answers are 3 and -9/2. And that was what I wanted to share with you for that part. I now need to do one more thing, and that is called factoring by grouping. Factoring by grouping. factoring by grouping. Again, these are much more advanced than what we did last time. So by grouping, for example, 12a to the third minus 9a squared plus 4a minus 3. How can you factor that? Well, let's try and put these two groups together. That's one group and that's another group. And then factor them and see if anything comes out nicely. When I look at this, what is common? I see a 3a squared. I can factor out a 3a squared out of these two. So what do I end up with? When I factor out a 3a squared, I'm left with 4a. When I factor out a 3a squared, I'm minus -3. Let's double check. 3a squared times 4a. 3 times 4 is 12. A squared times a is a cubed. Very good. What about this? There's nothing common to these two except 1. I can just put plus 1 times 4a minus 3. What do you notice? 4a minus 3 is common to these two terms. Remember we discussed that terms of an algebraic expression are separated by plus signs and minus signs. This is one term because it's a product. It's a product. This times this is one term. This times this is one term. So 4a minus 3 is common, so we can put 4a minus 3 times what is left outside, which is 3a squared plus 1. There's the 1 right here. I guarantee you, you can multiply this times this, you're going to end up with what's there. For real. Let's check. 4a times 3a squared, 12a cubed. 4a times 1 plus 4a. -3 times 3a squared, -9a squared. -3 times +1, -3. And when you write this in standard form, which means that you write it from the highest exponent in decreasing order to the lowest exponent, we now have what? 12a cubed minus 9a squared plus 4a minus 3. And this is the same as what we started with. So this is just check. That what we did was correct. Let's try another one. I should point out here that for the first question we did, we were able to group the first two and the last two. Sometimes that doesn't work. Sometimes you might have to mix the numbers up, move them around, and put them in closer proximity to other terms in order to group. So it's not always the first two and the last two. Keep that in mind. It doesn't always have to be like that. Okay, let's try another one. Okay, 2p cubed plus 5p squared plus 6p plus 15. Questions like these where you see it's in standard form, and it's very easy to see that these two are the higher degrees, these two are the lower degrees, then in those cases, the first two and the last two should be grouped. But there are going to be other expressions which we look at that will not be as easily discerned like that, where it's in standard form decreasing. Okay? So stay tuned for that. So here we go. What is common to this? The only thing I think we could is 2p, 6p. 3 times positive 5, positive 15. There it is. Notice 2p plus 5, 2p plus 5. So because those two things are common, I can put them together. 2p plus 5. And what's on the outside? P squared plus 3. Again, I guarantee you, if you multiply these two binomials together, you will get that expanded version. You will, I promise. Let's try something that is uglier. The two examples I've done so far have the same letter throughout. Let's try something that has stuff that's mixed up terribly. Try one way and it doesn't work, and you have to abandon it and try a different way. Nothing is wrong with that. It's part of the process. So you might try one way, it doesn't work, try another way, or try another way until you get it exact. So what can we group together? What can we group? Okay. Let's try and group these two and see. Let's group the first two and see what happens. Let's see. So if I factor out m, let's see what happens if I factor out m. I end up with m times z minus 5h squared. M factored out z minus 5h squared. Minus, let's factor out negative 5n. Negative 5n. What do we end up with? Negative 5n leaves a z. And if I have a negative 5 outside, to get a positive inside, this has to be negative. And 5 times 5. Let's double check. M times z, mz. M times negative 5h squared, negative 5mh squared. Negative 5n times z, negative 5nz. Negative 5n times negative 5h squared. Negative times negative is positive. 5 times 5 is 25. Nh squared. There it is. And notice that the two parentheses are identical, so therefore we can factor that out. So we end up with z minus 5h squared times what is on the outside, which is m minus 5n. I guarantee you this, when expanded, when you multiply these two binomials, you will get what is above. Guaranteed. Okay? So that wasn't too bad. Let's try something that might be a little bit more challenging. Okay, trying to run away. Here we go. Let's try this one. 12xy minus 28x minus 15y plus 35. 12xy minus 28x minus 15y plus 35. I wonder if that involves anything. Let's see. Suppose we did this. Would that work? And if we did that, would that work? Well, for 12 and 28, I think we can do 4. And there's an x here and there's an x here. So let's try 4x. Let's try that and see what happens. If I factor the 4x out of this, I end up with 3y. If I factor out the 4x out of this, I end up with negative 7. Let's double check. 4 times 3 is 12, x times y is xy. 4 times negative 7, 4 times negative 7, negative 28x. Perfect. Over here, if I factor out let's try and factor out a negative 5. Try and factor out a negative 5. What are we left with? Negative 5 factor leaves us with 3y. Negative 5 factorial leaves us with negative 7. Let's double check. Negative 5 times positive 3y, negative 15y. Negative 5 times negative 7, positive 35. So it works. And then these two are common, so we can write 3y minus 7 times 4x minus 5. So I thought that would have been difficult. That was not difficult. Let's look for another one. Again, these are far, far different from what we started out with. Far different. Okay? Let's go over to the other page and see if something more challenging is over there. Let's see. Okay, this looks pretty ugly. Let's try this. 75. A squared C minus 45. A squared D minus 30. BC plus 18 BD. Let me check to make sure I copied it correctly. 75a squared C minus 45a squared D minus 30 BC plus 18 BD. Yes, yes. Lots of things happening here. What is common? Well, I see 75 and 45. I see we can get 15 out of that. Okay? And we can get the a squared. So 15a squared. Let's try that and see what happens. If we did 15a squared. Wait a minute. I think we have something better. Wait a second. 75, 45, 30, and 18. I see we can factor out a 3 from the very get-go. We can factor out a 3. So let's do that. So this is equal to 3 times 25a squared C minus 15a squared D minus 10 BC plus 6 BD. All I did was I noticed that 3 is common to all 4 coefficients. Coefficient. 3 can go into all of them. So I start by factoring out 3. And now I'm going to group these two. So now we have 3. I'm going to use a square bracket. When I group these two, what do we end up with? 25 and negative 15, I'm going to go with 5. A squared, 5a squared. And then, what's left inside here? If I take out a 5a squared, I should have a 5c. If I take out a 5a squared, I should have a negative 3d. Let's double check to see if it's correct. 5a squared times 5c. 5 times 5, 25. A squared times c, a squared c. Perfect. 5 times -3, -15. A squared times d, a squared d. So the first part is perfect. What about this? What's common to this right here? I can think of -2b. Let's try -2b. If I factor out a -2b here, I get 5c. Factor out a -2 here, I get -3b. Let's double check. -2 times 5 is -10. b times c, bc. -2 times -3 is +6. b times d, bd. So it's fine. And then, of course, we see this and this, they are common. So if we start with a square bracket, we end with a square bracket. And now we can put this together and we end up with 3, 5c minus 3d times 5a squared minus 2b. Again, what did we do? These two are common. So we back it out right here, and what is on the outside goes here. What's on the outside goes here, and that's it. This, I suggest to you, is identical to that. If we multiply these two, and then take the result and multiply by 3, I promise you, you will get that. So this is a far cry from where we were the last time. The last time we were doing things like, what is x squared plus 2x minus 15. We were doing that last time, and look at us now. Wow, it's like miles ahead. But yet, we are comfortable with the process because we understand that there's a method to what we're doing. It's not random. There is a method, and if we stick with the method, we stick with the process, it will work. Let's try another one. Trying to make sure that the board doesn't run away. Okay, here's one that is even longer. 150 m squared nz plus 20 m n squared c minus 120 m squared n c, and finally minus 25 m n squared c. That's ugly. So let me quickly double check because this looks very involved. 150 m squared nz plus 20 m squared c minus 120 m squared nc minus 25 m squared z. And they want us to factor this by grouping. Now, as I look at this, I notice that there's a z here and there's a z here. So this has m, n, and z. This has m, n, and z. So don't you think those need to go together? This has m, n, and c. This has m, n, and c. Don't you think it makes sense for these two to go together? So these two go together and these two go together. I think based on the pattern, based on the letters, I think that makes sense. So let's move them around a little bit. So this is equal to 150 m squared nz minus 25 mn squared z, and now I'm going to write these two, plus 20 mn squared c minus 120 m squared nc. All I did was move this from the back, put it close to the first, and then these two are right here. So now we're ready to rock and roll. But I also look at this and I notice that 5 is a factor of all 4 coefficients. So maybe we should do that from the get-go. So we're dealing with smaller numbers. So here we go. 5. This is going to give me 30 m squared. Oh, wait a minute. I can do better than that. I see mn is also in all of them. So I can take out 5mn. This makes it a lot easier. mn. So I'm going to factor out 5mn out of everything, and that makes my life easier. If I take out 5, this gives me 30. If I take out mn out of this, I'm left with mz. When I do this, it's a minus 5. If I take out mn, I'm left with nz. When I take out a 5 out of this, I'm left with plus 4. When I take out mn, I'm left with nc. And finally, over here, take out a 5 from this list is 24. And you double check. 5 into 12 goes 2, 5 into 20 goes 4 times. mn, so I'm left with nc. That's what I'm seeing. So now, let's go to work and see what we can do. Is equal to 5mn times, I'm going to use square brackets. And these two I'm grouping. So what am I going to take out of this? I'm going to take out a 5z. When I factor out a 5z, what am I left here? I'm left with 6m. When I take out a 5z out of this, I'm left with negative n. Let's double check. 5z times 6m. 5 times 6 is 30. Z times m, mz. Whenever you have letters in the same expression, you put them in alphabetical order. So m goes before z, mz. Let's go over here. Sorry, 5z times negative n is negative 5nz. There it is. Come over here. What is common? I see 4c. So let's go plus 4c times. When I factor out a 4c, I'm left with n. When I factor out a 4c, I get minus 6n. I'm going to put our square bracket to close. Okay. Take a look. What do you notice? I see something. Do you see what I see? This is 6m minus n, but this is n minus 6m. So there is a difference. So we need to twist this so that this is identical to that, or that is identical to this. I prefer to leave this as is, and I want to change this. Do you realize that if I factor out a negative 1 outside, then this becomes negative, this becomes positive. Okay, so what we end up with is 5mn times 5z times 6m minus n minus 4c times, once we take out a negative sign, this is positive, this is negative. Let's double check and see if we're crazy or it's right. We're going to multiply these two and see if we end up here. Negative 4 times 6 is negative 24. M times C is NC, negative 24 MC. Negative 4C times negative N. Negative times negative is positive. 4C times N is 4NC, or 4CN. I know I wrote it as NC. NC and CN are the same, but it's proper to write it as CN because of the alphabetical order. But it's not a crime, but it's correct, but it's not proper. So now these two are identical, so we can finish the job. So it's 5mn times, these two are common, so we can now write 6m minus n, and these are going to be on the, the other set of parentheses, minus 4c. So this is the factorization of this long and ugly expression. I think you now have an idea what this thing looks like. We started very simple last week, and look at where we have reached. Something more massive, but we realize that if we follow this sequential, systematic process, it will work, and we'll end up with the final result. Many people in math world doing pure math would be very confused with this. But if you're willing to go step by step by step by step, it all comes together. Okay? So I hope this was very, very helpful. And on behalf of the Brosis Foundation, I want to thank you for spending this time with us. I hope you learned something, or I hope your curiosity was aroused. Please join us again on Thursday as we present another set of factoring more advanced algebraic expressions. This time I'll be doing factoring sum of cubes and difference of cubes. Looking forward to seeing you then. Enjoy your day.